Next topic we're going to focus on is sets and Venn diagrams. Right, so I think most of you guys seen a Venn diagram before. It's this thing here. It's just a useful way to just parse out information and solve things. But let's go over some like common terms so we all know what we're talking about. So in a Venn diagram, we have this thing called a universe or universal set right here, as you can see. So that's just everything that's in this particular Venn diagram. So only numbers you're going to see in this particular Venn diagram are 1, 2, 3, 4, 5. And that's the way it works, right? So here's a little subgroup called that A. A only has two elements, so we write like this, 1 and 2. Right, so a couple of things. A has two elements, 1, 2. If you ever see this, like right here, NA, that just means a number. So like writing this doesn't mean write the two elements, it means how many things are there. So there's 2. Right, the number in the universe is 6. So that's all that means. If you see the end there, it just means number instead of like which particular things. Or if I say A, it's like, oh, it's 1 and 2. And this you can see a lot in IB, or just in general. You'll see something inside something like that. That just means that that thing is an element of A. So like I could have right here to say X is the value of A. This means X is in here. It's like 1 or 2. IB actually uses it a lot in different types of problems. You'll see something like this. X is an element, like when you're solving, of Z. That's just like a shortcut. Z is an integer. So just trying to tell you, hey, the answer you're going to get is going to be an integer. It's going to be a nice number. Sometimes you see X as an element of N. An even nicer number, because that's the natural numbers. So it has to be like 1, 2, 3, 4, 5. And I think you also sometimes you'll see X as an element of R, which is a real number. It's like a fancy R. It can be any number you want. So if you see an IB, they're just trying to tell you, hey, your answer is going to be like an integer here. So it's going to be a positive or negative number that with no decimals. If you see this, it's just saying, hey, your answer is going to be a nice solid 1, 2, 3. If you see X as an element of R, the real numbers, then it could be anything. It could be a decimal, it could not be a decimal, it could be anything. Fraction, not fraction. So that's just, when you see that, don't get freaked out. That's all it's saying. It's like a little hint. You can just ignore it for the most part if you want to. But back to more Venn diagram stuff. So let's look at a little notation. As we talked about earlier, right? Universal set is just the U. The element A is something within it. So like this is element A. Right? So A is an element. A is the subset of the universal set. Now here, you see how there's A and there's anything that's not an A? A prime. I said before, right? That's A prime. It's the complement of A. Right? If you add A and A prime, or the probability of each one, I should say, you're going to get 1. Or if you have the number of elements in A plus the number of elements in A prime, right? Not the problem, not the odds, but the elements, you would get the universe, right? If you add everything in here plus everything in here, you get the whole set. As you can see right here, right? If this is my universe and A is only 2, 4, 6, A prime is everything else. So it's 1, 3, 5, 7. All right, everything that's not an A. A is this. A prime will be the rest. So that's just kind of the way that works. A and A prime. If you scroll down, you see some more stuff, right? Stuff we've seen before. Intersection, right? Intersection is the and part of these things. You have to be in both A and B. So if you look at two sets like this, where they interlock, where the elements are in both A and B, this little middle part right there, known as A intersection B. Right? It has to be in both A, it has to be in both B. Intersection. Union, it's a little more complicated, right? Union means it can be an A, or it can be in B, or it can be in both. Sometimes we call that a mathematical or. It can be A, or in B, or in both A and B. In English, you don't have that, right? English is either A or B. In math, we're a little more liberal. You could be in A, you could be in B, or you could be in both. That's the union. And I should have left it without coloring it in because it looks uglier now. But yeah, you commit, you gotta go. Okay, I think I'll stop. So that's the union though. A union B, it has to be in A, in B, or in both. So the inside mesh right there. And then finally, disjointed jets. Disjointed sets. They have nothing in common, right? So like if A was a set 1, 2, and B with a set 3, 4, they have nothing in common. So like this disjointed, also known as mutually exclusive. So when they say that, that's actually a keyword in IB or in general. It means that they have nothing in common. So you have to know that A intersection B equals 0. Very important. Mutually exclusive, that's all that means. They have nothing in common. So super important. When you see that, do that. So just keep that in mind. Right? Mutually exclusive means they have nothing in common. Intersection is 0. So let's actually do an example. Separate Venn diagrams containing two events A and B that intersect. Shade the So basically, just want to shade this thing. So let's draw and let's shade. I can talk. I'm good. So that's my square. Better than my lines sometimes. Here is A. That's a terrible circle, but whatever. And then here is B. So here's the important part. They want me to draw something that's in A but not in B. So I have to be in A, right? But I don't want to be any part of B. So A but not in B is strictly this part right here. Right? Because you're in A but you have no part of B. So in A but not in B. That's actually a very famous one. They do them a lot. So they'll say B not in A, which is this part right there. Or they'll say A not in B. It's actually one I've seen they ask a lot. Let's look at this one. Neither A or B, nor B. So you're not in either of them. Here's my universe. Here's A. Here's B. Now remember, this one says it doesn't want to be in any of them. It wants no part of A or B. So here's A, here's B, so you're out on the outside. Right, you're not in A and you're not in B. So stuff like that. So we'll do a little bit more of that in the future, but that's a general idea of how you draw Venn diagrams. Not in A, nor in B, so you're on the outside. Let's get this one down real quick so we understand the basic concept of how to do set notation and draw a diagram. Let A be a set of all factors of 6. So let's look at that real quick. All the factors of 6, right? So I need to divide 6. So 1, 2, 3, and 6. Let B be a set of all positive integers less than even integers less than 11, right? So B, all even numbers less than 11. Positive and even numbers. So 2, 4, 6, 8, 10. And then the universe is all the numbers between 1 and 10. So that's also important to keep in mind. And see how it says right there, x is the element of the natural numbers? I'm sorry, the integers. That just lets you know that x is going to be like 1, 2, 3, 4, 5, 6, 7. That's all that means. So first describe A and B using set notation. Kind of did it right there. Done. Illustrate A and B on a Venn diagram. So let's do that real quick. A, B. Now first I like to figure out the ones they have in common. So it looks like they have a 2 in common and a 6 in common. So that's going to go in the middle. So 2 and 6, they both share 2 and 6. Right? And then A has 1 and 3 that B doesn't have. So 1, 3 goes here. B has 4, 8, and 10 that A doesn't have. And now remember, our universe is all the numbers between 1 and 10. So universe is like 1, 2. And any of these numbers we haven't used yet goes on the outside of them, right? So we use 1, we use 2, we use 3, we did 4. We haven't used 5. 5's not taken. We use 6, we haven't used 7. We used 8. We have used 9 and 10. We have used 10, sorry. So, on the outside here, it's going to be 5, 7, and 9. Now let's really quickly look at this right here. So remember, NA, this means how many elements in A. So if you look at A right here, there's 4, right? Or if you look at right here, 1, 2, 3, 4. there's 4 elements in A. That's all that means. How many of them are there? A union B means, right, what's in A, or in B, or in both. So it's like 1, 2, 3, 4, 6, 8, 10. Let me put a little set notation. Curly brackets are hard to draw apparently, so you get that. And then intersection, it's what they have in common, right? It's just the middle here. So there's only 2 things, 2 and 6. And that's a basic overview of what a Venn diagram looks like, right? So you have these points, you have these values in A, you have these values in B. What they have in common goes right here in the middle, the intersection. If they have anything, what they have not in common, you put it solely in the A not B part. Now remember, all of A is this, but this is A not B. Anything that's in B but not A goes in this part. And any of the things that they don't have that the universe does have goes on the outside. And then from there you just solve basic things, right? Number of terms, it says how many are there. Union means anything in the circles basically, and intersection means anything in the middle circle they share. Okay, let's move on. If A and B are 2 non-disjoint sets, shade the region of the Venn diagram representing. So a little more shading, let's do a little more practice of this. So if I want to do this, draw myself a little square. Here's A. Here's B. I'm not gonna jinx myself. This says it actually looks kind of decent from my take. Now look what it wants. A union not B. So that's a lot more. That's a lot tough. They want A. So let me just like kind of circle what A is. And they want to union that with not B. Right? So here's B. I want not B. So I'm just gonna kind of do like vertical lines. Right? So this is all gonna be not B, right? Anything that's not in B is not B. And then A was, let me draw a horizontal line for A. What was that? Now, very important. They said the union, right? Now if they say intersection, I just want what they both have, which would be like this A part right here. But they want the union, which means it can be an A, it can be in B, or it can be in both. So the answer is going to be basically everything except for this part right there, right? Everything except for the part that's only B. All of this, anything that color touches, is the answer. Right? Like that. Again, more complicated. I'll do another one. Say this one here. This is also another complicated one. And I really don't have shading, so it's hard for me to be subtle with these colors. But here's the idea. Here's not A. So here's A. So not A is everything else. Right? Here's B. So B I'll highlight it in red. And then not B, I'll just do it vertically. So anything that's not in B. Right? And the question is, I want the intersection of those two. Where do those two things touch? If you look at my colors here, there's only red in here. There's only green in there. And where you're not in A and you're not in B would be all the outside. They get a little funky. But you're not in A and you're not in B, so it must be on the outside. So again, those are a little funky. I think they actually work better in class with the pencil, where it's not as where it's more forgiving. Anyway, let's go to an easier problem. So let's look at this one. This is probably something more you'll see on an IB test or just in general how to solve these problems. If the Venn diagram below, the Venn diagram alongside illustrates the number of people in a sporting club who play tennis and hockey. That doesn't sound like a rich, I'm not going to say it. Determine the number of people in the club, right? So the number of people in the club, you just add up all these people, right? The number of people that play tennis, the number of people that play hockey, the number of people that play both. So, actually before I do this, let's talk about these numbers. 15 is not tennis. 15 is only tennis, right? They don't play any hockey. 27 is people that play tennis and hockey. But 27 is also part of the tennis. So if you want to figure out only tennis, it's this whole circle. If you try to figure out people that play hockey, it's this whole circle. People that only play hockey would be 26. Right? And the 7 people here are neither. They don't play hockey or tennis. Like that's how those numbers work. Now I'm trying to figure out the number of people in a club. In this particular club, it would be 15 plus 27 plus 26 plus 7. Right? You just add up all the numbers you see there. That's the universe. Just add up all the numbers and everything. Number of people who play hockey. So it's hockey of any type, right? It didn't say only hockey, just hockey in general. It's this circle. So 27 plus 26. Who play both sports, right? So they play tennis and they play hockey. So that's the middle right there. They play both sports. Who play neither sport? That's these people right there. Who play at least one sport. Remember, at least one sport, so that means you can play one sport, like only tennis, or only hockey, or you could play both sports. So you have to type all that right there. It's 15 plus 27 plus 26. Right, so that's the way that works at this Yippity Yacht Club. The next one we're going to look at very quickly. So here's another Venn diagram. And this one I just want to show you the fact that there's numbers. So like in here you see these little dots, right? That little dots, if you look at those, you just count that there's 8. If you count this, 4 times 3 is 12. 12 plus another 3 is still about 15. So in the universe looks like this atom both up, you get 23. Right, and look what it says here. Number of people with blue eyes, I think that's supposed to be the E. Now remember, number they did number, so just counted it. So that's why it's just a number. Number in the universe, 1 over total, right? The key to everything. So you just put, 8 over the total, 23. People with not blue eyes, well, blue eyes are this thing right here. So not blue eyes would be everybody else, so 15. So 15 over 23. So that's just a quick way of how you use numbers and how it can be and cannot be. Let's go with something a little more interesting. And that's this right here. So again, these are the questions you're probably going to see the most of. In a class of 30 students, 19 study physics, 7 study chemistry, and 15 study both of these subjects. Display the information on Venn diagram, hence determine probably that randomly selected class member studies blank. So we're going to do this kind of thing. And we have physics, and we have chemistry. Right? Our universe is 30 students, because it says 30 right there. It's our universe. 19 study physics. Now, very important. Again, physics is 19. That is not this right here. It's this whole circle is 19. Right? Don't put it here. That's lazy. And 17 study chemistry. So same idea. This whole circle is 17. Not just this part. The whole circle is 17. So I got to figure out how many in the middle so I could parse it out. And luckily they tell me. 15 study both of these subjects. That made it easy. So that's 15. Now, right, if the whole circle is 15, that means in chemistry is 17. That means only 2 people are only taking chemistry. Same thing over here. If 15 is in the middle, and there's 19 people taking physics, well, 19 minus 15, there's only 4 people only taking physics. So now they wanted to know a couple questions. Right? How many people are studying both subjects? Well, you told me up here. I could read. So 15. But also down there. At least one subject. Now remember, at least one pretty much means A union B, right? So you could do this one, or you could do that one, or you could do more than one. So you just add up all this, right? So you could be physics only, you could be chemistry only, or you could be in both. At least one is basically the whole thing. So 4 plus 15 plus 2. So again, and actually I'm a little wrong. It said probability. So what's the odds of picking it? 15 out of 30. What's the odds of picking this one? 14 plus 15 plus 2, which would be 21 out of 30. Right? It's a probability, and there's 30 students in the universe. That's your total. How about the next one? Physics, but not chemistry, right? So you want physics people, but you don't want any of them taking chemistry. So it's only this part right here. It's like half crescent. Right? They're only taking physics, nothing else. So that's 4. is actually one of the subjects, well, that means that they're not taking anything together, like not taking both. They're only taking one. So it's they're either taking physics or they're taking chemistry. So 4 plus 2, 6. And then neither subject. So like this is interesting. We haven't talked about this yet. Notice if we add up all this, which we did earlier, which I didn't write down though, so 21. All this equals 21, right? The union right here equals 21. Well, there's 30 kids in class, or whatever where study was. So you subtract them, there must be 9 on the outside. And that's always how you find neither. The universe minus the universe plus neither. Oh wait, I said that wrong. Sorry. The universe equals the union plus the neither. So once you have either universe once you have the union or the universe, you can figure out what the neither all the time. Or if you have the universe and neither, you can figure out what the intersection, the union is. Okay, let's move on to our last example. We'll skip that. It's getting a little late. So we're gonna do another one of these. Again, these are super important. It's one I'm gonna do lots. It's the last one we're doing for today. We will see this again. So 50 married men were asked whether they give their wives flowers or chocolates for the last birthday. The results were 31 gave chocolates, 12 gave flowers, 5 gave both. If one of the married men was chosen at random, determine the probability that he gave his wife blank blank blank. So we're gonna do kind of the same way. Make a little table right here, a little Venn diagram. Now we're gonna do a Venn diagram, not a tree diagram, because look at the sets. You're not choosing options. You're just going, hey, I have 50 people, and they're broken down this way. Perfect way to do a Venn diagram. So first, my universe is 50. You need to know how to do that. And I either gave chocolates or I gave flowers. Now, again, 31 gave chocolates, so this whole circle is 31. I cannot stress that enough. It's not this thing, the whole circle, right? And then 12 gave flowers. It's supposed to be like a F, I guess. So 12 gave flowers. And then they're being nice and say 5 gave both. Okay, well, here's 5. But again, once you have that, a lot of the rest is academic. Okay, 5 gave both. There's 12 total in this circle here, so that means there's only 7 left over. 31, right, gave chocolates, and then 5 gave both, so that means there's only 26 left over there. And if you're trying to find the outside, right, well, the thing I talked about earlier, universe equals the union plus the neither. Universe is 50. The union I can figure out really quickly. You just add all this up. 26 plus 5 plus 7. 38 plus n. So the neither, just subtract 38 from both sides, is 12. 12 people did not give their wives chocolates or flowers, so they're probably divorced now, but whatever. So the first part, chocolate or flowers. So remember, that's like the union. That's the thing we just found. Chocolates or flowers, right? So they gave chocolates or they gave flowers or both. So you just add 26 plus 5 plus 7. I think you should be 38. Now look at the next one. Chocolates but not flowers. So that means only chocolates. Right? So where's the only chocolates at? That 5 doesn't count. That 5 gave both. So it's only chocolates. That's only this right here. So 26. Only chocolates. Then neither, like we found in our Venn diagram right here, the soon divorced gave neither. So you get that, 12. And that's the idea. And we are done.